Hello, everybody, and welcome to Clearwater Innovation, where we generate awareness of the global water crisis through our website, events, and educational programs, and encourage children to utilize their creativity to alleviate the problem. Today, I have with me Alexis MacAvoy from Hillsborough, California. She will be talking about her project, designing efficient, low-cost, eco-friendly activated carbon for removal of heavy metals from water. Alexis is a 2019 Broadcom Masters finalist and the winner of the Robert Wood Johnson Foundation Award. Hello, Alexis. How are you?
Hi, I'm doing good. Glad to be here.
Thanks for being here. So let's talk about your project. What problem were you trying to solve?
Well, as of right now, 80% of the world's industrial wastewater isn't filtered whatsoever. This can have disastrous effects on the environment and our human health. So, like in the gold rush, when mercury was used to mine gold and was merely dumped into the bay, causing problems for centuries and millions of dollars to clean up. In order to prevent that issue from ever happening again, we need to have accessible filtration so that our health and our ecosystems won't be affected.
That's really interesting. So what was your solution to this?
So my goal was to design efficient, eco-friendly, and accessible activated carbon so that lower income countries and places that normally do not have access to a lot of proper filtration can use activated carbon instead of just dumping it into the water, like in this background picture. I coagulated different methods that proved to be the most efficient and safe for removing toxins from water into one procedure for developing activated carbon, which I acted out in my garage and tested using a variety of assays.
What is activated carbon?
Activated carbon is carbon generated from burnt plants usually that is stickier and traps more toxins like heavy metals and such. So the stickiness comes from the halogenation that I included after activation with two different halogens, sodium fluoride and sodium chloride, which attracts mercury and in this case copper. And then the porosity also helps trap the toxins, which is why I discussed the importance of a Mesoporous and Microporous structure.
So Alexis, why did you decide to use Biowaste Precursors?
Other than availability and cost, Biowaste Precursors supply a lot of benefits to the activated carbon structure. Their lignin, hemicellulose, and cellulose properties contribute to the meso and microporous structure of the carbon, which helps trap the different toxins. So in order to choose the right precursors, I had to delve into some research and figure out what plants had the best cellulose and lignin content, which was important for the porosity, and definitely using waste that we don't need is really important and taking another step and helping our environment.
So can you define what microporous and mesoporous mean?
Well, porosity is a huge factor in how well activated carbon works. So microporous are smaller holes and mesoporous are more medium-sized holes. And through research, I found that a combination of microporous and mesoporous size porosity works best to trap heavy metals. So I tried to maximize those with high cellulose and lignin quantities in my precursors.
Really interesting. So how is your solution an improvement upon current filtration systems?
Well, according to my spectrophotometric assay, which determined the levels of copper before and after activated carbon filtration, my homemade activated carbon worked 30 times better than commercially available activated carbon. And an important factor is that I used biowaste instead of previously burnt carbon, and cheaper reagents and safer reagents such as phosphoric acid instead of like zinc chloride or sulfuric acid as my main activating agent.
Very cool. So how did you utilize existing academic literature in order to assist you in your research process?
I used a lot of papers and journals to help me get further in my project because since I was at home in a garage, I was unable to do a lot of big fancy experiments to figure out figure out some factors. For instance, the cellulose and lignin percentages of my precursors I had to find online because I do not have a chemical reactor. Generally, time researching saves a lot of time in the lab, and also in my case, a lot of money because I do not have those resources.
So you mentioned that your project is completely from the garage, which is really impressive. Is there a specific method or like a creative procedure that you use to simplify your project in order to make up for not having access to fancy materials in a lab?
Yeah, I definitely had to overcome a few obstacles due to accessibility, which was actually a key part of my project, so that went well. My initial intent was to try and test the activated carbon's abilities at removing mercury from water, since that closely ties into the San Francisco Bay's problem, and I live near that area. But mercury is toxic, and I could not safely access that and work with mercury, so I used copper instead. I also went to eBay and other various online stores to get cheaper equipment and kind of improvised with like temperature holders and water baths and such.
Very cool. So how do you take steps to preserve ecosystems and water on a personal level?
Well, we definitely all have an impact on our environment, such as not littering, trying to conserve water and such. But we also want to be aware that there are a lot of companies and industries that are polluting the waters quite a lot, and just kind of trying to promote that idea of proper filtration. And hopefully the industries will use some filtration later on.
So what are these said industries that cause a lot of heavy metal pollution? And how can we get them to stop? Is it awareness, or is it an economic thing, or what are the big steps we can take in terms of that?
I think the biggest issue is definitely accessibility. In my area and generally the US as a whole, we are pretty good with filtration because we have the financial ability to do that. But as you go to less lower income countries and regions, their filtration abilities decrease, and there's not as much impact of non-monetary means. So we kind of need to work on accessibility and getting that to those places.
So where are you going to take this project in the future?
Well, I've worked on a second year study this year. I'm also going to try and publish a paper reporting the conclusions of my studies and also the safety of my activated carbons, so that hopefully more people will see my work and try to reach out with other places that they know are in need of proper filtration and just generally spread the word.
Nice. I'll look forward to reading that. So you're going into your sophomore year. Good luck with that. Would you have any advice for your younger self, say maybe going into middle school or elementary school?
I'd say determination and creativity are really two key factors in problem solving. There are a lot of obstacles, especially if you don't have lab access, which is pretty difficult to get. So you have to try a lot of different paths to overcoming those obstacles and just not give up, you know? There are many different ways to approach a problem, and don't be disappointed if one way doesn't work out.
That's great advice. Thank you so much, Alexis, for joining us. You can find her blog write-up and other great resources at www.clearwaterinnovation.org. We would also appreciate it if you followed our Instagram at We Impact Community. Thank you so much for watching.